Greetings to everyone. In this video, we'll be looking at the reinforcement design for pi head. So here, we'll be looking at the formula that I already explained on my previous video, the one of effective depth, the tensile force, the reaction, number of steel. We'll also check spacing of a reinforcement and also look at the maximum moment. Okay, here as you can see here, the effective depth is equal to h minus c minus theta over 2. If you want the effective depth is here, is from the bearings here. Bearings are here, right? Bearing to here, down here. And then we have this part is the part beneath the bridge deck, this portion. So if you want to calculate the tensile force on your bridge column, you have to use T is equal to reaction times a length, this length here, the length from the first load to the second load. This is the length from P1 to P2. This is the length. So you say T is equal to reaction times load divided by 4D. This D stands for effective depth. And then when it comes to the reaction, if you want to find this N, the reaction, you say N is equal to P1 plus P2. This is the P1. P1 is from here to here, and then P2 is from here to from here actually, because this is the load. It's from here to here. This is the P1, and then this is the P2 from here to here. Okay, if you want to calculate your load, the first load is from here to here, from here to here. Then the second one is from here to here, here to here, right? And then if you want to calculate this length is already, I have already shown the length. Length is here on this diagram. Length is equal to 2 loads. Length is equal to 2 loads because it's from P1 to P2. Then we have 2 loads. Okay. Number of floats are here. See, number of floats here. Okay. If you want to calculate the number of steel for a load, okay, if you want to calculate the number of steel, you'll say area of a steel. This area of steel, the area of steel is equal to tensile force divided by 0.87. Here there's a, you see, T over 0.87 times the y height. Times y. This is the distance actually, not y. This is the distance here. Times d, distance, not a depth, but a distance here. This is the distance, the y distance here. Times y distance. Okay, you'd say For number of steel is equal to area of a steel divided by AS. The AS is here. AS is equal to pi theta squared divided by 4. Pi theta squared divided by 4. This is the AS. And then if you want to calculate, right now I'm still trying to show you the formulas. Later on I'll show you all the workings, so you just show you equation to workings on how to do workings based on this reinforcement designed for a pi head. Okay, when you check the spacing of reinforcement, when you check it, the formula is, it says the spacing here you are looking for the spacing of reinforcement. Spacing of a reinforcement is equal to load at depth. The load at depth should, they mean the load from here, the depth from here to here. So it's the load at a depth divided by number of steel plus 1. And then the units for spacing of reinforcement is millimeters. So to say load at depth divided by number of spacing plus 1. Here, as you can see, here is the diagram. So now we will be looking at the shear zone. Here is the diagram. The reaction from a cheddar. So our shear reinforcement. As you can see, this is the overturning moment here. Then the reinforcement is here. And then here also there's a reinforcement here. And then we have a centroid here. Centroid is here. Overturning moment again here. Then the distance here. The distance from this distance is from P6 to P7, but it goes together with the lesser weight of a column. Goes together with it. So I'll show you the shear reinforcement formula. The shear reinforcement formula, it says shear reinforcement equal to P6. It is P6 from here. It P6 plus P7 plus P8 plus weight of a column, the weight column, right? The weight of a column, right? Okay, and then if you want to calculate the maximum moment, you say P6, it is P6 times lesser distance times x6 plus P7 here, P7 plus the x7 distance here, the x7 distance. The x7 distance is from x6 to P7. This is the distance for P7 plus P8 times x8. Then the distance for x8 for P8 actually, plus the x distance times weight of a column. That is the formula if you want to calculate the maximum moment of the column, the maximum moment. Here, as you can see, the bending moment diagram. This one. The shear reinforcement is here, and then the compression reinforcement is here. Okay, thank you guys for watching. please make sure you click the like button and subscribe. See you in the next video.